Myself, Ashit Kumar.
And myself, Najmudheen. We both are working for a project called OpenSTS. It's a Linux Foundation project. Today, we are talking about telemetry and anomaly detection using Prometheus. And in this session, we are going to cover what is Prometheus, what Prometheus can do, what Prometheus cannot do, why Prometheus is so famous. And we'll also talk about how Prometheus is used in OpenSTS for telemetry and anomaly detection. So,
Okay,
just
quick thing. How many of you are aware of Prometheus or have used Prometheus? Oh, quite a good number. Okay. So you have used also, right? Great.
Right. Yeah, so
Then that will be an interesting talk then.
Right, so this is, first we will talk about Prometheus, a basic understanding of Prometheus. Then we'll move on to how Prometheus is used in OpenSTS for telemetry and anomaly detection. Yeah, so Prometheus is a time series database and a monitoring system. And it is open source. It has got a very powerful query language called PromQL. Prometheus is so famous because, first of all, it is open source, right? And it supports all famous operating systems. And it has got a powerful query language. It is multidimensional. When I say multidimensional, you can query Prometheus using different ways you can query Prometheus. Like it's not like SQL, it's so simple. And Prometheus is a GitHub project. You can see Prometheus in GitHub Prometheus repository. It's mainly written in Golang. Its operating system cross-platform support, Apache free license, right? Yes. So let's look into the architecture of Prometheus. If you see, the center part of the heart of Prometheus is Prometheus server, right? You can have, based on your deployment, you can have one or multiple deployment of Prometheus server. Prometheus server contains retrieval module, time series database, and HTTP server. Time series database uses the locally attached disk for storing the time series data. A retrieval module retrieves metrics from exporters or from push gateway. So there are two ways to get metrics into Prometheus. One is through exporters, one is through push gateway. We will talk about the difference between push and pull in our coming slides. And we'll talk about job exporters also. Now, so we have Prometheus collection, Prometheus persistence in TSDB. So Prometheus handles all the parts of monitoring system, right? That is why Prometheus is famous. Prometheus collects, Prometheus persists, Prometheus helps you to visualize, Prometheus helps you to alert based on the collected data. So for visualization, Prometheus has its own Prometheus web UI where you can visualize the metrics. And Prometheus has support from Grafana also. How many of you know about Grafana? Right. So Grafana is a famous visualization tool for time series data. So Grafana has supported Prometheus as a data source in that. And obviously, you can have API clients which connects to Prometheus server and query the metrics using PromQL and use your own dashboard. You can create your own dashboard. And alert manager is there. So Prometheus has alert manager. So whatever the collected metrics, we can create some alert rules in Prometheus. Based on the rules, Prometheus triggers some alerts into alert manager, And from alert manager, we can manage these alerts. Alert manager processes it, aggregate, and send this alert into multiple notification platforms like PagerDuty, email, or Slack. So you can configure where do you want to receive your alert. Similarly, Prometheus is famous for dynamic environment. Right? Dynamic environment, when I say, like Kubernetes, like things are moving around. People, the nodes will get added, services will get added, goes down, right? This kind of dynamic environment, Prometheus is very suitable because Prometheus has a service discovery. Prometheus connects to this platform and discover the services from where it can scrape metrics from, right? So this is very brief about Prometheus architecture. TSDB is time series database. Yeah, so let's talk a little bit about the data storage format in Prometheus. Prometheus has on-disk time series database, which is usually local disk attached to Prometheus. Prometheus also has support to integrate with remote storage systems. So for that, what Prometheus does is Prometheus defines a standard output and input. So when Prometheus writes data into a remote URL, they write it in a standard format and write it into a remote URL. The remote storage system, it can be a database also, can read from there and persist there. So basically, how it does is adapter will be there. So we have to write an adapter which understands both Prometheus standard and the remote storage system standard. That's how the integration with remote storage system is achieved. And Prometheus uses its own time series database. And each block of data consists of 2 hours time series data, right? And a directory of a block contains an index, chunks, tombstones, and WAL files. Index says from when start time to end time of the time series. Chunks holds actual data, the timestamp and value. And tombstones is used when we optimize the queries. Like tombstones hold the status of deleted time series, right? At what time the time series is available and not available. So that information is there in the tombstones. WAL files are used for crash discovery in case if the system fails or crash. The WAL files contains the latest metrics available and the write back will be initiated. So again the metrics will be returned into TSDB. Yeah, so this is data storage format. And Prometheus has got a very simple data model. So as you know, in the time series database, we need a timestamp and value. Each metric in Prometheus has got a metric name, some labels. Each label is a key value pair, right? So key value pair, a key, and it has got a value. And it has, the metric has got a value. So this is a simple data model of Prometheus. This is why Prometheus is multi-dimensional, because each metric in the Prometheus can be identified by using different dimensional queries. Like you can just say events process total, that will select this metric. You can also say instance equal to 10 to 244, 298. That also matches this particular metric, right? So there are different ways to identify a metric. Right, so, yeah. So that's what Prometheus has its own data format. It uses chunks. So each chunk consists of a timestamp and a value. And they have inbuilt compression technique in that, where they only store the delta of values, right? Timestamp is there, delta of values, right? So as I said earlier, Prometheus has 2 collection mechanisms. One is pull and one is push. So pull mechanism, if you see, Prometheus Prometheus has got exporters, and any resources which Prometheus scrape metrics from is called targets of Prometheus. So to get metrics from a target, we have exporters. Now what Prometheus does is, Prometheus scrapes in intervals. We have to set the interval in Prometheus configuration file, the scraping interval. So during that scraping interval period, it will connect to the exporter endpoint and scrape the metrics. Now what exporter does is, exporter collect metrics from the resource and keep it in the plain text format as in the data model, and the plain text response will be read by Prometheus. This is a pull way of collection. Now push gateway, sometimes exporters need not be running all the time. So what happens is, some application, some processes comes up, it collects, send it, and it goes down, right? So in such kind of use cases, what we do is a pull mechanism where exporter or any other job collect metric from the resources, it push the metric into push gateway. Now push gateway is configured as a scrape target in Prometheus, and Prometheus will scrape metrics from push gateway. This is another way of collecting metrics. Right, so Prometheus has a very powerful query language. It is more simple than SQL. So just to query a metric, you can just give the metric name, and if you want to filter out, we have available operators like equal to, not equal to, less than equal to. So operators are available. And if you want to select a particular range of metrics, we can select the range of metrics by specifying the range, seconds, minutes, hour, in a square bracket. And it has also got operators, addition, subtraction, logical operation. Aggregation can be used by applying some function, sum, min, max. Also on aggregated metrics, on range vector metrics, you can also apply some functions like increase, rate. So these all are inbuilt functions available in Prometheus. Yeah, so I have already told about Prometheus has connection with these ecosystems: Alert Manager, Prometheus Web UI, Grafana, exporters. So exporters are not in Prometheus Prometheus repository. Exporters is a different repository where any third party can come and write exporters, right? So we have exporters for all the components in the IT stack, like for DB, for networks, for compute, for storages, right? So we have already available exporters available in GitHub. So whoever wants to use exporters can just download exporters and use it. Right, so Ashit will cover telemetry and OpenSTS integration part. Yeah, just.
Okay. So we are talking about this time series database and all the data that is coming in, right? So everyone has it in mind, right? The data is the key. The data deluge that you see. So we need to act upon those data, because data lying somewhere or data not getting used somewhere, that is like a problem, right? So we, in OpenSDS, we went into the data, like how to collect the data and how to do the telemetry and analysis over there. So from this, OpenSDS is a single pane of glass to manage heterogeneous platforms. So heterogeneity is one of the key things that OpenSDS provides, right? You have different computes, you have different storage, you have different, so for storage, for the sake, there are multiple players here, over there. Even in the compute, there are multiple players. So you need to provide a single platform which will ease out managing all this data from different compute to the different storages, right? So that is where the OpenSDS plays the parts. And for smart management, we need to collect the data, persist it somewhere, to visualize it, analyze it. As we were talking, the data lying somewhere, it is like a waste of storage that you are having, right? So you need to analyze that. Now, if something goes bad with the data, there is some issue with the data, there's some remediation that needs to be thought upon. You need to alert. So say, for example, a storage admin or a server admin will need some alerting mechanism, right? And based upon that, they need to have some decision making. Now, all this is like quite a troublesome task, right? Different tasks are bits and pieces, they are lying everywhere, right? Now, you need someone to orchestrate or to automate. So, automate and then orchestrate it so that it eases out the tasks, right? So, that is where OpenSDS does, like it orchestrates and automates. Okay, so if you see right now what the compute, like if you see in a OpenStack or Kubernetes clusters, each have their own stories, right? OpenStack, there are multiple OpenStacks. Then Kubernetes, they are writing to the persistent storage. Then OpenStack is using different, for the block, for the file, they are different. Objects, they have different storage mechanism, right? In the Swift and Manila. Now, what OpenSDS does, as I said, someone needs to play a part to ease out it for the end users, right? That is where the OpenSDS solution comes. So you have different computes, that is the northbound. Then you have different storages, that is the southbound. Now OpenSDS sits in between and eases out. So for example, someone wants to write, the VMware compute wants to write it to the storage, right? So there, OpenSDS will just do the data management, like data proliferation and the data, whatever, like the facilitating the data to the storage. That is where OpenSDS comes. Now, it is something like easing out in the way that we are sitting in between. We will, you forget about, you just tell us about the computes and the storage, and we will need to facilitate it. And we talked about this Prometheus, Grafana, and all. So there needs to be some use cases around that, right? So over here, how OpenSDS uses Prometheus. So it can be like a third party which says OpenSDS metric API uses metric API. It goes to the controller. It collects the data from different. Naju was talking about the exporters and all, right? So it goes to the LVM metrics driver, Ceph driver, Ceph, you know, the on-premise storage that we have, LVM, then the third-party metrics driver. It collects the data, pushes it into the Prometheus server. Now, when it is getting pushed, you can get that data through the PromSQL that we talked about, get it, and it can be used for the telemetry and analysis. Same, the OpenSDS, the Grafana is the visualization that OpenSDS provides. Through the Grafana, you can check all the telemetry data that you have collected. And again, the data that is lying there, we were talking about, like someone needs to act upon. Someone needs to know what is happening with my data. If something is wrong, we need to alert. And that is where the alert manager comes. So it pushes the alerts to the alert manager. We'll go more into the alert manager thing. And this is what the metrics interfaces are. You write these functions, the base functions, the metric specifications and all that you write. This is for the collect metrics that is we have.
Yeah, so OpenSDS allow vendors to write their own metric drivers.
Right.
So what they need to do is they need to fill this interface. So if a vendor X wants to have metric driver in OpenSDS, they need to write a driver which supplies this metric spec. So that is the requirement to have a new vendor addition in OpenSDS.
So it is something like providing an interface which someone can use. Now for the LVM metrics, what we use is the SAR, LVM SAR, that is the system activity reporter, and we use the IO stat also. So that is what you get the resources, the volume, you get the IOPS, read throughput, write throughput, all the latency and all that information you can get it. Same for the disk, you can get those information, whatever the IO activities you are doing, whatever the throughput or latency information you want. If there is some issue with the throughput, there is some issue with the IOPS, you need to take some action, right? So that is what it provides, the metrics. Same for the Ceph metrics. You have this, we use this Rados gateway as exporter that collects all this data, and you can have the Ceph pool information, Ceph cluster information, all this data is collected. That is how the telemetry works. This is just a visualization of the LVM metrics in Grafana. This is one of the screenshots that we have taken that we provide in the OpenSDS. So that is what LVM metrics in Grafana, that how you can visualize it, the graphs and all.
Yeah.
Okay, so now Nazul, we are talking about this alert management and all, how to push the alerts and then get the notification, act upon that. So Nazul will talk about
Yeah,
alert
so,
management.
so now we know how OpenSTS collects data from multiple targets and how Prometheus is used. Now, for alerting, what we do is we can define some alert rules in OpenSTS, and these alert rules can be pushed into Prometheus. Now, Prometheus does the processing of alert rules while it collects the metrics. And when alert rule satisfies the condition, when the threshold meets, it sends an alert into alert manager, and then the alert can be managed from the alert manager console. And OpenSTS allows you to launch the alert manager console from OpenSTS dashboard. And once the alert is there in alert manager, you can see the alert, you can configure the alert to send into recipients. Right, so that is one use case of OpenSTS telemetry. Another use case of OpenSTS telemetry is anomaly detection. So as he said, we have collected the data. Now we have to make some meaning out of the data, right? So what we have in OpenSTS is an anomaly detection. So this telemetry controller part we have talked about, how OpenSTS collects that. Now there is a message broker comes in OpenSTS, Kafka, where the collected metrics is being pushed to Kafka as well, and the anomaly detection module reads data from Kafka, and anomaly detection module applies some algorithm on that, detects some anomaly, and then post a alert into alert manager. So let's see the detailed anomaly detection architecture. So we have a telemetry controller to collect the metrics, and anomaly detection mainly have a data generator, data parser, training services, and prediction services. What data generator does? Data generator periodically post some request to telemetry controller to collect the data. It can be some cron jobs, periodically running cron jobs, which collects data, and the collected data goes through Kafka to the data parser of anomaly detection. A data parser parses the data and stores it into the database, and there we have two services. One is training services. So many samples, we train a model, and once the model is ready, then the incoming metrics will be compared against a prediction service, and when anomaly is detected, the output will be given, and a post alert request also will be sent back to the telemetry controller. So this is how the anomaly detection works in OpenSTS. Right. So this is a sample of anomaly detection where we have a Gaussian model applied on LVM metrics using some 6,000 sample data, where we have removed some data which is 0, because if you consider 0 for modeling, then it won't be a right model. And these are some of the parameter which this algorithm takes, mean, epsilon, and all. And this is the output we received. So the red points of the statistics can be considered as anomaly. So what's next? So OpenSTS is evolving, right? So we are collaborating. So many people are contributing to this. Now we have collection from LVM, Ceph, and some other storage drivers. We need more data collection. We need collection from multiple platforms. So people can contribute, write drivers to collect data, and to correlate metrics, we can also use already available exporters. And then for anomaly detection, we want to consider more algorithms. So as of now, we have considered only some algorithms. So we need contribution in OpenSTS in the AI and ML field, like which algorithm can be considered for detecting anomalies, different kind of anomalies. Yeah, so the OpenSTS journey is on. So we are growing. We are going towards forming a foundation. So we have a SODA forum coming afternoon of this session. Right, so that's about telemetry and anomaly detection in OpenSTS.
Okay, so as Naju was saying, like if you are working on some telemetry or anomaly detection solution, or you have some inputs, please provide us. We have the Slack channel, we have the email alias, so you can reach out to us. We'll think of that. So again, as he was saying, that we are going to form a foundation where different projects can come and they can have their own contributions. So we are there for your contribution, your help, and please reach out to us. Okay? And to more, there will be more data management and more things about this. Even on the telemetry and anomaly detection, there will be a few talks that will be coming in SODA forum. So please join us over there.
Yeah, I had a quick question. I think one of the challenges with Prometheus is that it doesn't support long-term storage, and
Which one?
long-term storage,
Long-term storage.
like over a period of time, like in 2 years, 3 years,
Yeah,
and the
yeah.
fact that it doesn't support downsampling.
Right.
In your architecture, have you looked at using Thanos? And have you heard of Thanos?
No, no.
Thanos is a project from Prometheus, I believe, where it supports these two things, especially downsampling, deduplication of data and stuff.
Okay, okay.
I just wanted to know, in your architecture, have you considered using Thanos?
As of now, we have not looked into the retention period of Prometheus, because Prometheus has a default retention period.
Correct.
Yeah, so as of now, we have not looked into that. Probably it's a scope
Okay.
for improvement.
And you are right, like Thanos, we'll check about that.
Right.
That is another plan. So we saw some data docs over there. So we'll get.
Cool. And also, one more quick question I had was on your machine learning models that you mentioned.
Right.
It looked more interesting, really. I just want to know, are you using any third-party
Can you have screen
surveys
back
or
on?
something like that to train your models? How are you doing that?
Naju?
As of now, TensorFlow.
TensorFlow. Okay.
Yeah, TensorFlow.
Okay. So you're using TensorFlow for
Yeah.
this. Okay. Okay. Thanks a lot.